Mr. Sunil for giving a nice introduction. First of all, I thank Dr. KRISHNAN for inviting me, as well as IPI Pune chapter for inviting me to give a talk on PET recycling. Thank you for that. Let me share the screen. I hope you are able to see my screen.
Yes.
Okay, and my audio is also okay?
Yeah.
Okay. Today I will be talking about both the chemical as well as the mechanical recycling, especially with respect to the PET. If you see that, so far we have produced 18.2 trillion pounds of plastic worldwide, which is equivalent to 1 billion elephants, 80 million blue whales, more than 8 lakh Eiffel Towers, and 25,000 Empire State Buildings. We have produced such a huge amount of plastic. And if you see the PET, it is lightweight in nature and it reduces emissions. That's why it has replaced the bottles as well as the metal containers. And it gives low carbon footprint, and then it uses less water in productions, and then it costs 50% less when compared to the other alternatives. And if you see, India is one of the highest PET recycling rate globally. That is, we are having 90% PET bottles so far produced is recycled. PET is safe. Unlike a polycarbonate, there is no BPA issues, bisphenol A issues, and then it is free from that, as well as it's free from heavy metals. And over 70 lakh people, either they are directly or indirectly, they are associated with the PET industry, and then they are also supporting the circular economy. And if you see that, more than 100 crore garments and home textiles, they are all made from recycled PET bottles. Earlier, I was working in Futura Polyesters. That time, what they used to do that, they collect the waste PET bottles and they do chemical recycling. And then that chemically recycled one is again exported to USA. That time they were exporting to Pepsi for making use of the chemically recycled PET for again making the PET bottles. That they were doing it. Okay, if you see the PET, this is the percentage wherein used for filling water 34.6%, for soft drinks 27%, and for other drinks, fruit juices and all 11.2%, 11.2, and thermoforming 6.6, and for non-food contact 12%. This is the way the PET bottles is used for packing all the food-related matters, food-related contents. And if you see the mix of beverages in the worldwide, if you see that, PET is 30%, followed by glass bottles 23, cans 18, 10.8, 16.7. PET is not able to completely replace the glass bottles and cans, even though it is having a lot of positive attributes. For example, if you see that glass bottles, still you will find beer is packed only in glass bottles. PET is not suitable for that because of the very stringent requirement for packing the beer. Because if you want to pack a beer in a PET, it's very, very challenging issue. And usually what they do it, because the reason is that the requirement is that it should not have an ingress of more than 1 ppm oxygen if you want to pack a beer. Otherwise, what happens, the taste of the beer goes off, and as well as it gives them better UV protections because they put a brown color. And apart from that, it is easy to do the pasteurizations with the glass bottles. That is why the PET is not able to replace completely glass bottles, as well as the cans. If you see the small PET bottles, especially 200 ml and all, still the cans is economically easy, feasible. And then whereas the PET is somewhat expensive because it is not able to give the required CO2 barrier. If you go for packing a smaller amount of PET, that is about 200 ml. That is why today, even in the market, you see the cans only for packing 200 ml soft drinks. Let us see the per capita usage. If you see that North America is having 15 kgs as far as the PET is concerned, and we are on the lower side, we are hardly 150 grams. We are having the low usage, per capita usage, because we are always take fresh fruits, as well as we always take freshly brewed coffees. That is also one of the reasons that our per capita usage is still on the lower side. And also water also we prefer to take it in a bigger cans rather taking in a water bottles. That is why we are on the lower side. And if you see the global market, the highest growth rate is expected in African continent as well as in the Asian continent and Australia. And there will be a medium level in the case of both North and South America. And in the case of Western Europe, it will be on the lower side. And then the IMARC group expects the market will reach to 15.2 million tons by 2026 when compared to 13.1 million tons in 2020. So for such type of huge growth rate is possible, is having a very good future prospects. And if you see that the average life expectancy today is 69 years. Whereas if you see the bottle, that can be remain as such for 450 years. Therefore, if you leave the bottle, then it creates a lot of problem to the environment. Therefore, it should be properly recycled it, so that instead of leaving it to the landfills. This is the time frame for different materials, and then bottle takes the 450 years. And if you see that in India, some of the most common types of plastic consumed, if you see that the first is polyethylene, followed by polypropylene, then comes PVC, and PET, if you see that 1,275 kilotons. This is a report given by the Plastic India Foundations. This is what the Indian scenario as far as the PET consumption per year. And if you see that the PET bottles are all plastic items which are available along the Indian coastline. This was the report given by the Beach and Beyond. These things, you will see that around 6,511 plastic bottles are lying along the coastline. Therefore, these are the things, even though as we think that 90% is a very, very good amount and we are above the average of PET recycling, still that 10% either remains in the landfills or on the roadsides, still that remains unutilized. Therefore, we should make use of that for recycling it and make it on 100%. Therefore, if you see that the waste the generated by 2015, it will touch 25,000 million metric tons. And if you see that the waste recyclings will be hardly, you will have 8 billion metric tons or 8,000 million metric tons. Therefore, still a lot of the gap is there between what the waste is generated and the recycled one. Therefore, by 2050, we will see that roughly 12 billion tons of plastic waste will end up in landfills, and then it creates a lot of work to the natural environment. Therefore, we should always encourage recycling it so that you can minimize the plastic waste instead of going for the landfill. And if you see that the overall plastic waste recycle is around 60%, PET recycling is 90%, whereas the world average is only 22%. We are on the better side, but still long way to go. And we look for the search of solutions because that much of huge amount of waste lying, and this is not a new scenario. You might have seen on many parts of our country, such type of scenario looking for solutions. And if you see, what do you mean by recycling? Recycling, it saves energy, it preserves the natural resources, it reduces greenhouse gas emissions, and it keeps toxins from leaking out of the landfills. That is why the recycling. And let us see that how the recycling concept came into existence. Let me see that. I will tell you that in the next slides. And then if you see the various options available, the most favored options is that reduce the waste that you produce it, reuse the material again and again, recycle the material to make new products. If it is not possible, then go for the recovery of energy from the waste. And if none of these four options are available, then go for the landfill, which is the least favored option. This is what from most favored options to least favored options. And if you see that in the 1980s, there was no recycling concept and everything was going to the landfill. Therefore, what they were doing it, they used to dump in the as a landfill. They used to do it. Therefore, what happens in the New York? What happens is there was a land scarcity. Therefore, immediately what they did that they took all the 3,000 tons of the plastic waste, since there was a land scarcity in New York. They put it in the Marlboro garbage barge ship, and then they were trying to send it to the neighboring state. Therefore, the ship traveled here and there. It was traveling 150 days looking a place so that they can dump these 3,000 tons. First, it was sent to North Carolina. They refused to take in. Then it went to Louisiana. Then they also refused it. Then they sent to the Mexico. Then finally they sent to the South African countries. Luckily, none of these places they accepted these plastic waste to come in, and then they were to remain as a landfill. Therefore, it was again sent back to the New York. Then only the concept of recycling comes. Till then, it was just going as a landfill only. Thank that that they refused to allow in. Otherwise, still we will be only confining to landfill. Afterwards, the recycling concept came into existence. And if you see that today we are giving different numbers. This is the recycling symbol, and this was developed by a student. He's a very young chap, 23 years. Dean Anderson, he created this recycling symbol in 70s, and that is being used today. And there are different numbers are given. The PET is given 1, the HDPE 2, 3 PVC, like that, and none of these 6 is given as a 7. If you see any recycling symbol with a number, that tells what kind of polymer it is. Luckily, throughout the world, the same number is used. Whether the bottle having a number 1, whether it is from India or from Australia or from America, means it's only a PET. There is no confusions. Everybody is luckily following the same number, so that anybody, any layman, if he takes it by seeing the number, he will be able to easily sort it out. That is why this number came. And if you see the classifications of recycling, there are 4 types. Primary recycling, which is nothing but the recycling that you do it in the shop floor. When a material is not meeting the specifications and it got rejected, then what they do that they used to do the recycling. It is straightforward recycling. There is no confusions and there is no need to do any segregations and no need for any cleaning. This is a straightforward that is being used in all the industries. If any material got rejected, then typically they use around 10% and then they consume it. The secondary recycling is the one which goes after reaches the customer. Secondary recycling, generally it will be mechanical recycling. Here a lot of things you have to do it. You have to do the cleaning and then segregations, and then you go for the mechanical recycling. Tertiary recycling is the chemical recycling. In today's talk, I will be talking about mechanical as well as the chemical. The fourth one is a quaternary recycling, where you will get the energy or the fuel value of the plastic waste, either by incinerations or pyrolysis. As far as PET is concerned, quaternary recycling is not the right options. This is what I was telling, that the granules are produced and then you make different kinds of plastic articles. Then once it gets rejected, if it is not meeting the specifications, then you try to consume it rather throwing it out. That is known as primary recycling. If you fill it with a different one, consumer, then afterwards, if it goes to a waste, then either you can go for a mechanical secondary recycling or go for a tertiary recycling, make a monomer, and this monomer again you can polymerize it. Otherwise, if you not possible all these things, then you send for quaternary recycling. As far as the PET is concerned, if you see that the calorific value of the PET is very much on the lower side. It is 22 only, whereas the coal is 30 and then heating oil is 42. That is why PET is not the right material for the quaternary recycling, because it's half of the heating oil or coal. Whereas if you see the polyolefins, the PE, PP and all 46 and 44, that is why the polyolefins is the most suitable one for replacing the coal or the heating oil, whereas the PET is not suitable one. Therefore, I will be confining to the secondary and tertiary, especially the mechanical as well as the chemical recycling. This is what the waste is collected. Then initially they do the sorting out. Then once all the PET is collected, then they bale it. Then it is sent to the place where it is recycled. Then what they do that they first crush it out, they wash it, then regenerate, make a semi-finished products, and then finally goes to end products. This is the cycle how they do the recycling. And then the lot of separators is used, because sometimes you may have some metal contaminations. In that case, you have to go for a magnetic separators, and sometimes you may have non-ferrous contaminations. In that case, they use a eddy current separator. And to go for a sensor-based separators, if you are having a lot of waste, and based on the sensor, it differentiates different polymers. If the volume is less, go for the manual sorting. That will be expensive, and then that also contains error. Whereas the sensor-based one, it's a very, you have to do a lot of capital investment, but it will be 100% free from errors. And then you need this is not suitable for sensor-based separators when the volume of the waste is very much on the lower side. Let us, before going into the PET, let us know that for the common man, PET is only a bottle. But if you see that the body, it contains 3 polymers. The bodies consist of PET, and then the PP, generally PP will be the closure, and then typically the label will be the PVC. Therefore, when you crush it, you have to see that the closure PP should be removed, and the PVC label also should be removed. Now, the recent thinking is that why to have all the 3 polymers, and that gives a lot of problems when you go for a recycling. Therefore, they want a single polymer, whether it is a body, whether it is a label or closure. If everything is made up of PET, then it will be easy. No need to removal of PVC or PP is needed, and then you can straight away go for the recycling it. But currently, since all 3 polymers are there, you have to remove it. PP is easily removed it, since it's having a density lower than 1. When they wash it, it starts floating it, the PP is removed it. PVC label, they remove it by the classifier, air classifiers, these labels, that they do it, they remove it by means of air classifiers. If you see the India, that 90% is the recycling rate PET, followed by Japan 72%, Europe 42%, and 31% in the US. This is what PET recycling rate. And finally, when you do a recycling, either you can make other polymers, or again you can send for again you can make a bottles, or you can go for making yarns or for these strapping applications. And if you the 90% it goes into any of these applications, and only the 10% is just goes as a landfill, or it still lies with somebody else. Let us see the mechanical recycling and then chemical recycling. If you see the mechanical recycling, it preserves the molecular structure. You melt it, and then again you make some product. During that process, the color deteriorates, the strength also deteriorates. This is what is happening it, and finally you have to go for a downcycling applications. And then if you go for a chemical recycling, what happens that it splits the polymer chain, and as a result you will get the raw materials. Once this raw material is there, again you can go for the polymerizations and making. As far as the food contact applications is concerned, chemical recycling is the best method when compared to the mechanical recycling. Why it is so that the PET bottle, sometimes it may be abused. They might have used for filling some acids, some phenols, or some other purpose, or sometimes even for in some rural side, they may also put some pesticides. In that case, if you do for a mechanical recycling, then those toxic substances can get into the food contact applications. Whereas if you do the chemical recycling, since you are doing the depolymerizations, those toxic chemicals can be easily removed it, and then the monomers again you can make it. That is why in the future they were doing a chemical recycling it, and then they make it again, sending it back to Pepsi for making the soft drinks bottles. And let us see the mechanical recycling. If you see the mechanical recycling, everybody might be knowing that from the PET bottle you can make a t-shirt by means of a mechanical recycling. The reason is that the beauty of this, that the PET bottle, if it is used for water applications, the intrinsic viscosity will be 0.72. If it is used for soft drinks applications, it will be of 0.80 because it has to withstand the pressure. And it is used for hot fill applications, especially for filling fruit juice and all. Usually it will be 0.85. When you do mechanical recycling, there is a drop in molecular weight. As a result, the IV drops to 0.6, which is the suitable intrinsic viscosity requirement for making the garments. And that is why the t-shirts are made. And this is what they recently also, the Indian cricket team, they were using t-shirts made up of the plastic bottle. In this case, one thing one should know, that when you are making yarns, the removal of PVC is very, very critical. Because what happens that if the PVC is not completely removed, the PVC decomposes during the processing of the PET waste. During that time, the PVC decomposes and it gives a charred one. And if these charred one, when they do the melt spinning, it blocks the spinneret, and as a result, you may not be able to have a complete continuous productions. It will get stopped because these blacks, the charred materials, it goes and blocks the spinneret. Therefore, this is the problem when you go for these things, if you are not removing the PVC. Suppose if you want to again go for making bottles, by me again going for a solid state polymerizations, the PVC remains as the black spots in the preforms, and when you blow the bottles, then the bottles will burst in those places, because those are all the weak places. Therefore, in the recycling one, unless you remove the PVC very completely, you will get into a problem while making the yarn, either for the yarn applications or when you go for the bottle applications. That is why it is very, very critical. That is why now the thinking is that we will go for a single material rather than having a PP, PVC and that of a PET. And before going to the chemical recycling, let us see, we should know a little bit about the PET productions. Most of you, 99% of people might be knowing that, but just for understanding or for continuity, I'm telling that PET is typically produced from the terephthalic acid, purified terephthalic acid and ethylene glycol. Initially, they were manufacturing it from the DMT. That time, the terephthalic acid, the purification of terephthalic acid technology was not available. They were making only impure terephthalic acid. Therefore, during those times, they were making dimethyl terephthalate for making the PET. Then later on, when the technology comes for making a purified terephthalic acid, all the industries, they moved from DMT to that of a terephthalic acid. The reason is that it gives higher output because you don't have a byproduct, methanol, whereas in the case it will be water. And another one is that you need also the MEG requirement will be on the slightly on the lower side. That is only 15% excess than that of a 20%, and you need a less amount of the catalyst. Therefore, everybody migrated from a DMT to that of a terephthalic acid. Whereas when you have a DMT, you should have a very fireproof should be there. Otherwise, the byproduct methanol being a flammable one, it will create a problem in the industries. That's why the moment the technology is there for making a purified terephthalic acid, everybody migrated to the PTA technology. And today, 99% of the industries, they are using only PTA for making the using the PTA for making the PET. Let us go for the chemical recycling. Suppose PET, you can try it with either hydrolysis, glycolysis, methanolysis, ammonolysis, and then you can make other polymers also, polyurethanes or unsaturated polyesters, that we will see that. If you do hydrolysis, the PET, when it undergoes hydrolysis in the presence of sulfuric acid, you will get a terephthalic acid. When you do it with the sodium hydroxide as a catalyst, you will get the sodium salt and finally treat with the sulfuric acid to make a terephthalic acid. This was the hydrolysis process. They do it so that the PET can be brought into the earlier materials, especially the terephthalic acid. This is one way of doing it. The other one is the methanolysis. Therefore, you have to use a high pressure around 3 megapascals at 180 to 200 degrees centigrade, and PET undergoes methanolysis to make a DMT. Then this DMT will become a starting material. In the case of the hydrolysis, the PTA will become the starting material for making the PET. Let us go to the glycolysis. This is what the Futura was doing it. They were doing the ethylene glycol. They were doing the glycolysis. As a result, what you will get is that you get the BHET dimer, then it comes BHET. Then again you do the polymerizations. As a result, what happens from the PET waste, you will again you depolymerize it, followed by polymerizations. You will get the chemical recycle, that is glycol. Using the glycolysis, you are able to make it one. This is what they were doing it, the Futura. And then another one is that from glycolysis, you can also make some polyols. Once if you make a polyols, then this polyols can be treated with the isocyanate, especially the diisocyanate, MDI, so that you can make a polyurethane. And this polyurethane can be used as a coating for the insulation applications. The Huntsman, they are doing it. They are making the polyester polyols. And later on, this polyester polyol is making for different kinds of energy saving applications that they were doing it. Therefore, instead of making the original one, they were making the polyols, and this polyols is used for making the MDI based polyurethanes. Then another one, from this polyols, if you treat with the malic anhydride, you can make the unsaturated polyester resins. This is one way of converting the PET to that of the polyester resins. Then another one, if you see that instead of using the ethylene glycol and make it as either you go for polyols or you go for the BHET, what they do that instead of using ethylene glycol, they were using butanediol. And once butanediol is used from PET bottles, you can make PBT. Currently, the SABIC is making it, converting the PET into PBT, and this PBT is widely accepted, is widely welcomed in Japan. And the recent LCA studies also says that there is a reduction in the global warming by 29%, and then the cumulative energy demand also is reduced by 43% when compared to the PBT, because PBT is widely used in the automotive applications. Therefore, from the PET bottles, they were making a PBT, and from this PBT, you can see that there is a reductions in the case of the global warming as well as on the energy demand. This is what SABIC is doing it. And then you will have aminolysis, wherein the amine is used. They use ethylene diamine to make it that is amide linkages. You can introduce it in the polymer. This is one way of doing it. Or go for an ammonia, where you will make a terephthalamides, and this you can use it for making the polyester amides. Therefore, from the PET, you can, if you want, by means of chemical recycling, you can go back to PET, or if you don't want, you can use the PET to make it a PBT, or you can go for making a polyurethanes, or make it as a terephthalamides to make a polyester amide, or treat with the malic anhydride to make an unsaturated polyester. These are the various options are available, and especially for foot contact applications. If you want to again use the PET for the foot contact applications, the best thing is to go for the chemical recycling rather for the mechanical recycling, because the mechanical recycling, any accidental toxic material, if it is present in the PET bottle, that will not be removed at all. And then now recently also, now everybody talks about the 3D printing. Therefore, what recently they found out that from the PET also one can make a 3D filaments, and later on that they can do the 3D printing. This is a newer applications. They have studied it, but it's very, very infant stage that one can do it. And this is the printing temperature. It's about 160 to 210 degrees centigrade if you want a 3D printing. This is the paper wherein they have told that the PET can also be used for a 3D printing applications, which is because 3D printing is a new concept and everybody is interested to work on these things. And now this is PET can also be used for making the 3D printing. And finally, I would like to conclude with the statement of Stephen. Plastic is still a fantastic, wonderful material, but the end of the life of the plastic has not been thought thorough enough. We need to find solutions to continue to use plastics. And still the usage of PET is going to increase in the coming decades. We need more and more recycling, and we need more and more newer solutions so that these PET waste will not get into the land, either go for the landfill or it will not. Therefore, one should look for newer solutions so that you can make use of the PET, which is a very, very, even the plastic is a very, very wonderful material that one can do it. Thank you very much. If anybody wants to ask any questions, I am always there. Thank you.